All right, so here's my beginning class to teach secure coding. And so the first thing you're going to need is a public server, a public Linux server, so your app can be accessed from the outside. So you can set it up on the Google Cloud for free. I've been using this for years. This totally saved my Black Hat exploit development class using these free cloud servers, so it didn't depend on a local installation or VMware or anything. If you just go to Google with a Google account, you can create a Google Cloud account, which is free, and they'll give you like $300 of free credit. And here's the rule: a Windows cloud server costs $10 a day to run, but a Linux cloud server costs $1 a day to run. So if you make a Windows server, you have to be sure and turn it off when you're not using it. But if you make a Linux server, $300 is plenty of money to run this thing for almost a year. So you just create Compute Engine virtual machines just by clicking through a cloud menu, and you will end up with virtual machines. And I've got some. Let me get to them. Here they are. All right. Let me clean this up a bit. All right. So these are my virtual machine instances on the Google Cloud. And I'll try and make the font bigger. There. I have two of them. I have a Windows machine, which is turned off, like I say, because it'll cost me $10 a day every time it's on. And I'm actually paying real money for these because I just haven't been motivated to beat up some certificates. But this one's $1 a day when it's on, and I turned it on a few hours ago. So this is my Debian 12 headless cloud server, which is what I always like using. And so it has an internal IP address, which is private, and has an external IP address, which you can reach it from the outside. And all you have to do is click SSH here, and it will let you control it with SSH right here in the browser, which is really handy. You don't even have to have an SSH client or put in a key or anything locally. It just connects you directly. It's a little bit slower than launching it from the command line, but it's so easy. I use this all the time. You just click authorize. It will check my Google login, and I'm in. I'm now into my Linux cloud server. So you can totally do fun things here. And that's what I made all these projects based on, because it's the easiest for students to set up. And now I can test apps in the cloud. So the next project is to make a PHP server. After you've got a Linux server going, then you want to install a few tools so you can put web apps on it. So all you have to do is install Apache and some PHP libraries so you can have web pages and you can have PHP code in your web pages. So now the typical thing people do to test PHP is you make a PHP info page. So this here, all web pages go in this directory var www.html by default. So if you look at that, there it is. It's PHP info. That's all it is, nothing much to it. And so now you can see that. So you go to the cloud page here and copy your public IP address. So I copy this, and now I go to that location, which is here, HTTP, I'll just put it in here, http:// and that IP address. And if I go there, I'm going to see the default Apache page. This is what you get when you install the Apache server. It makes it like a test page so you can tell it's working. And then if I want to see that PHP info page, let me fit my things on the screen better. We're done with this one. There, see here, I made a file called phpinfo.php. So I just put that here. And there it is. It shows you just general information about your PHP installation, including, as we mentioned in one of the web app things, it shows you your environment variables, which sometimes contain secrets. And that's why it's considered a poor security decision to leave this page visible. But we're not worrying about that here. This just verifies that not only is Apache working, PHP is also working. So once you got that, then there's a couple flags to find to prove that you got it working. And now you can start making web apps that are vulnerable and patching them. And so I'll just show you the cross-site scripting one for now. This is where you make the simplest ones. So if I look at this file, SC201.htm, this is a web page. And as you can see, an extremely simple web page. Let me make my font bigger, which is font size. All right. This just is a form which will input one variable called the name and send it up to a script, SC201.php. This is about the simplest HTML form you could make to handle some data. And so then you make the script, which is going to run it, which is ending in PHP. And the script is also incredibly simple. It takes data called the name. If there's nothing there, it gives you an error message. If there is a name, it just says hello name. It just echoes back your name. So that's all it does. So to see this thing go, you just need to put SC201.htm in this page, which somehow I don't have anymore. I'll get it again. Go back to my cloud server, which is here. VM instances. I'll get this this IP address again, copy it. That's what I need. So here, I do HTTP and put that in, and that's the default page. And then to see this thing, it's SC201, no space, 201.htm. There. Whoa. All right, what did I do wrong? Slash SC201.htm. There we are. This is my form. All it does is take a name. So if I put in the name like Sam, it says, hello, Sam. About the simplest possible active web page you could have. But of course, that means if you put in a script, alert, one, script, it's going to echo that back on the next page and pop up a box. So this is the simple reflected cross-site scripting vulnerability. It does not filter out dangerous script tags, and that's the point. So you make this thing, give it the vulnerability, and then you can test it. This is why you're using a public server, so I can verify that you've made a vulnerable page and that you fixed it. So you go to this page, and now it needs the URL to your PHP script. So here, it's this thing, except ending in PHP instead of HTML. So I can test my script here, and the students can. You have your publicly available server on the cloud, anywhere you want to make it, and this is like a vulnerability scanner I wrote. It's, of course, nothing more than a simple Python or PHP script that sends a simple thing to your site to see if it works. But this will now check your page, and if it's right, it'll give you a flag. And it's going to check to make sure that it does, in fact, echo things back and that it does have that vulnerability. And then you fix it two different ways. First, you're going to fix it by removing, the script is what pops up. So the first thing is remove these two characters. That's one way to fix it. And then you can verify that that has happened. And the next one, this is a weak defense, filtering out characters. What's far better is to HTML encode characters. So you preserve them so people can use them in names like apostrophes and quotes and stuff, and you just replace them with the HTML encoded version, which will now display correctly, but they will not be misunderstood as active script. And so that's the second fix. And so after you got that, there's a whole series of the common vulnerabilities here where you make a simple vulnerable page and you fix it. And then there's other ones after that, but that's all I wanted to show you. So you might want to try that stuff. Let me stop this recording.